Hi guys. So what I'm about to show you is actually extra credit because strictly speaking, it's not necessarily an expectation in the geometry course that you're going to be using quadratics. However, the vast majority of you will be going on to Algebra 2 or Algebra 2 Honors next year, and you will be expected to remember how to use quadratics, how to solve them, using factoring, quadratic formula, or whatever method you choose. So I want to show you how to approach these examples, just in case you choose to try them, to see how they would work. Right now, we're in your Unit 10 classwork packet, and we're on page 18. Once again, Unit 10 classwork packet, page 18, and I want to take a look with you at question number 13. All right? Now, number 13 on the surface is actually not that difficult, right? Because all I have is I have a chord and I have another chord, right? Now, what makes it a little bit tricky, though, is notice that for this one chord, I have x's as both pieces. What that's going to do when I multiply them with product of the pieces, that's going to create a quadratic. So watch as that happens, all right? So 12 times 10, that's pretty easy, right? That's 120, but I'll write it as 12 times 10 first, and that's going to be x minus 1 times x plus 6. Now, those of you guys who had some of the algebra teachers at Cooper last year, they probably taught you something called foiling, right? First, outer, inner, last, and that's fine. My personal preference, though, is to think about it as double distribution instead. Meaning, I'm going to take the x and distribute it to the other parenthesis. Then I'm going to take the negative 1 and I'm going to distribute it to the other parenthesis. So let's watch. So I'm going to get x squared plus 6x minus 1x minus 6. Then I'm going to combine a few like terms, all right? So 6x minus 1x is 5x. So I get x squared plus 5x minus 6 equals 120. But then I got to remember to solve a quadratic, I got to get everything on one side, right? Because I want to use zero product property, and I can't use that unless I have 0 on one side. So I got to subtract 120, right, from both sides here. So minus 120. And then I'm going to get 0 equals x squared plus 5x minus 126. Okay, so we get to this point, right? And the question is, what exactly do we do about it? Well, at this point, you have a couple of options. Let's say you wanted to try factoring, right? I'm going to be honest with you, I have absolutely no idea what multiplies to give you negative 126 and adds to give you 5. I'm sure there's probably something, but I simply don't know. So if you don't know, what you could always do is you could always use the quadratic formula instead. Quadratic formula, if you guys remember, says negative b plus or minus the square root of b squared minus 4ac all over 2a. So if I do that, I get as follows. Negative 5 plus or minus the square root of 25 minus 4 times 1 times negative 126, all right, all over 2 times 1, which is 2. So negative 5 plus or minus the square root of 25, 4 times 126, let's see. That would be 504, I think, all over 2. Negative 5 plus or minus rod 529 all over 2. And this is actually really nice because 529 is a perfect square. So I got negative 5 plus or minus 23 all over 2. And in this case, because we need a positive value for x, right, it wouldn't do to have a negative length. We're only going to use the plus. So negative 5 plus 23 is 18. 18 over 2 is 9. Bam. So again, the reason this is extra credit is it's a little bit beyond geometry. The focus of this problem is more algebra, right? Once you get past the initial product of the pieces, you have to use quadratics in order to solve for x. However, I think that many of you guys are probably capable of doing problems like these, but you have to remember how to FOIL first, right? So first, outer, inner, last. And you also have to remember how to factor by finding two numbers, then multiply to give you the last part and add up to give you the middle. All right?